Good morning, good afternoon, good evening, wherever you are. Welcome to the 29th Annual Yale International Society of Tropical Forester Conference. We are so excited for being able to come in together this year in person, but also allow the hybrid session to have a wider access to our online audience. We are so excited that you can join us online and so excited for people who come in to get together in person to discuss everything in tropical forest. We are opening with our first panel today, and we will have our open plenary keynotes address tomorrow as well. Many hybrid sessions to come, and please refer to our agenda on our website for what is available hybrid and what is available in person. And now I will pass it on. Oh, sorry, forgot to do an introduction. My name is Angela Xue, and I'm a second-year Master of Environmental Management student at Yale School of the Environment. And because this is our first year trying the hybrid version or hybrid format for the conference, if there's any hiccups on the way, please bear with us. We are trying our best to bring this the best experience for both our online and in-person audience. And now I will be passing it on to our team member, Leah. And Leah will help us to kick off the session. She has worked very hard along with Chamri, our other team member, to put this session together. And over to you, Leah.
Okay, hi everyone. So I've been co-planning this panel with Chamri. I'm a second-year Master's of Forest Science student. And we are really excited to have you here in person as well as our Zoom audience. So our panel today is called Feedback Systems in the Tropics. Our goal for this panel was to bring together scientists from different backgrounds and fields to kind of have a conversation on the natural science side of the feedbacks and potentially feedback loops happening in the tropics. It'll be moderated by Dr. Paulo Brando. He's coming from the University of California, Irvine, and he's the new professor at the Yale Center for Natural Carbon Capture. He's done work on forest degradation and causes of deforestation and how that will impact the future of tropical forests. So I'll hand it off to Paulo to introduce the panelists, and then we'll get started.
Thank you so much. Can you hear me? Okay. Yeah. Okay. To start with, I'd like to just thank the students and congratulate them for this amazing conference. So let's give them some. Part today to put together this amazing group of speakers that you have today, and I've seen dozens, if not hundreds, of emails to get everyone here or on Zoom. And I don't want to spend too much time here. I don't want to steal their time. And but just quickly, we have an amazing group that for this panel. And it's super good. Teacher, but everyone who depends on that. And here today we have Grizelle González, and she's director of the International Institute of Tropical Forestry under the Department of Agriculture and the U.S. Forest Service. Thank you so much for making your way, and apologies for the wait that you had to experience in New York, JFK, but that's an experience. We also have online Deborah Lawrence, climatologist, and she's for environmental sciences professor at the University of Virginia. Thank you so much, Deborah, to agree and participate in this panel. We also have Dr. Simon Lewis, who's a professor of global change science at both universities of College London and University of Leeds. Thank you.
Need more mic.
Okay.
Switch it on.
Is it okay? Is it better? Okay, let me turn this one off. Yeah, okay. I think you heard the previous names. Okay. And we also have this collaborator, long-term collaborator, Yadvinder Malhi, a professor at Oxford, and if I'm not mistaken, one of the directors of the Environmental Change Institute at the School of Geography. I won't spend much more time here introducing. The bios are online at the conference, and they're amazing, very detailed. And so to start the panel, we have 7 minutes, hopefully talks, short talks should be the main point, and then followed by about 5 minutes of discussions. Hopefully come up with your questions, and then we're going to go over after each speaker. We have time for questions, and then we'll have an overall discussions, hopefully half an hour. And to kick things off, we start with the broad climate forest feedbacks in the systems. And we're very lucky to have Deborah Lawrence to talk about this topic. So Deborah, the Zoom is yours.
Thank you so much for having me. I just got a little button that says I cannot share while the other participants is sharing. Maybe you could stop sharing and I will share. There we go. All right, thank you so much for having me. I'm really excited to be here. I love the topic, that interconnectedness, feedbacks, and adaptation couldn't be better for what I want to talk about with you today. So I'm going to talk about tropical forests, and the big point is that forests are much more than a big old stock of CO2. When you think about forests and climate, we should be thinking much more broadly, because tropical forests are the global climate connector. Also, tropical forests are key, not just for mitigation. They don't just help us address climate change. They're key for adaptation. They help us figure out how to adapt to climate change. So as you know, just like all plants, forests, tropical forests are made of CO2. So the forests that we have today absorb more CO2 every year. And as they do that, they actually take care of about 1/4 of all of the emissions that we put into the atmosphere by burning fossil fuels. So that's a huge service. When you think about forests and climate, tropical forests especially, they're taking care of a lot of our emissions. So forests absorb, that's the green bar below, and tropical forests are responsible for a lot of that. But tropical forests also emit. You know, you think about deforestation, it emits a lot. In fact, if forests were a country, they would be the second largest emitter after China and just a little bit more than the US. So forests matter. But forests also regulate climate by actively changing the energy balance of the earth. They do this in 3 ways. They change the way water moves, the way air flows, and the chemistry of the air. So what happens? Well, forests are dark. You think of them as a dark covering on the planet. They absorb sunlight. When they do that, they are taking in energy, and they use that energy to transform water. So water flows as liquid into the plants, up through the trunks, out to the leaf surface where they engage with photosynthesis. These water molecules, some of them are used in photosynthesis, some are just floating around, and they are transformed either inside the surface or at the surface, inside the leaf or at the surface, into water vapor. That process, moving from liquid to vapor, is called evapotranspiration. And that actually takes energy. So that process cools the air. It cools the air around the canopy. This feature is so great because of all the leaf area in a tropical forest that it actually cools the entire region. But the physical structure of the tropics and of all forests actually cools the atmosphere as well. You can see that the flow of air along a flat surface, it just flows. The air just keeps moving. It stays at 2, 5, 10, 20 meters over. And so all that heat that's come into the planet, it just stays there. But when that parcel of air that's moving along encounters a forest, it creates a turbulent flow. And the turbulence ends up mixing the air and basically pushing hot air up higher into the atmosphere. That leaves it cooler for us and for nature and for agriculture on the surface. The third way is that forests change the chemistry of the air. Again, all plants have the ability to make these things called biogenic, volatile, organic compounds. They do so to protect themselves. They either do so in the process of protecting themselves from insects, but they also protect themselves from heat. And so these little compounds are created. This is what makes a pine forest smell like a pine forest. That's one of these BVOCs. So how does that affect the climate system? Well, they interact with the chemistry of the atmosphere, and they actually create particles called aerosols, and those are very reflective. So they keep radiation from hitting the planet. That's a huge step in terms of avoiding global warming, is just keep the temperature down by keeping radiation going back into space. So they increase albedo. They also are cloud condensation nuclei. So they make clouds, and the clouds themselves reflect incoming radiation. These are huge effects. They're so big, and yet we ignore them. So say we removed all of the forests in the tropics from, say, 0 to 30 north and south, encompasses the tropics. The blue bars show you the temperature effect of doing that. And you can see that, if you added up all those blue bars, it's about 1 degree. That's just the CO2 effect. That's what we always think about. So we know right now that the tropics are keeping us cooler simply by being there. If we didn't have the tropical forests, we'd already be warmer. But what we don't count is the black bars, additional cooling due to those biophysical effects and BVOCs. It's substantial. So tropical forests are especially powerful. They're a giant, vast area of forest. They are where the sun comes in, beating down. They have a lot of moisture, so they can just do a lot of work changing the energy balance of the planet. But so they affect general process of temperature regulation, but they also do more than regulate temperature. When they do this changing of energy, they're actually giving us rain. So the way that they move energy and water gives us rainfall, important not just for the tropical forests themselves, but for all ecosystems nearby, including urban systems and agriculture. So say we were to remove all the tropical forests using a general circulation model or an Earth system model. And I just want to make a plug for all of you to think about trying to figure out how to learn about climate models. I only started doing this maybe 12 years ago. Like, I already knew what I knew. It's not too late ever to learn something new. And climate models are worth pursuing. So say you use a model. It's the only place you can deforest the entire world is inside a model. You can do that to learn about how forests work. If we take away all the tropical forests, we end up with 10 to 15% less rainfall in the tropics. That's a big deal. It's not the same across the whole tropical system. If you removed all of the Amazonian forest or all of Central Africa, you end up getting about a 15% reduction. In Southeast Asia, remove all the forests, you only get about a 5% reduction. Super interesting. It's because if you look at this picture, you can see all of that gray area around Southeast Asian forests. That's the ocean. And the ocean ends up overriding effects that you would see in these big continental masses like Africa and South America. So it affects all of the tropics. It affects it differently. But here's the thing, you deforest the tropics, you also have impacts around the world. So if you deforest Amazonia, what I'm showing you here, and the inverted triangles are places where rainfall goes down, the circles are places where rainfall goes up. These are examples of teleconnections, connections between something happening in one place on the climate, an effect on the climate elsewhere. So clearly you remove the tropics or you remove rainforests in Amazonia, you can have big impacts around the world. The same is true if you remove forests in Central Africa or in Southeast Asia. So here's the thing though, we don't experience average rainfall. We don't experience average temperature. What we experience, what we live with is the weather. And what we worry about is extreme weather. And it turns out, I'm not showing you 1,000 graphs, but tropical forests in particular, but all forests, they minimize daily temperature. They minimize the maximum temperature. So they keep us cool when it really matters. They give us a less severe, shorter, and fewer hot periods. They give us shorter dry periods. They also lower our flood risk. Forests are critical in stabilizing climates. So it's not just this global effect. They affect what people live in. They affect way more than the average. So forests everywhere do this, right? All forests do this. They reduce extreme weather. They are really affecting our risk and our vulnerability, the vulnerability of people and the ecosystems on which we all depend. In this session, we're focused on the tropics, and the tropics are important because they are this massive forest, this belt of forests that are so important, but also the tropics are already close to the edge. They're already hot. When we talk about lowering daily temperature, lowering maximum temperatures, reducing hot periods, it's really critical because they're already very close to the edge. So I want you to think throughout the conference about tropical forests as the global climate connector. And think about the fact that they do more than store CO2. The biophysical effects amplify the effects, their storage of CO2. They regulate more than temperature. They regulate our rainfall. We can talk about those atmospheric rivers in California, yes, probably something to do with forests somewhere else. Forests help us deal with more than just average. They define the extremes. They minimize extremes. And finally, tropical forests should be considered way more than a tool for mitigation. It's not just how forests can save the planet, save the climate system. Tropical forests are going to be essential for adaptation for the people living in the tropics. Thank you so much.
Deborah, thank you so much for this amazing talk. We have time for a few questions.
Thanks, Deborah. That was a wonderful talk. I wanted to ask, and I realized you couldn't touch on this in only 7 minutes. But if you could talk a little bit more about what we know about the role of volatile organic compounds and what we don't know, sort of where are the big gaps there?
That's a great question. What we don't know is we don't have a great handle on, say, what's the change from now to the future. We know that forests are really important in terms of creating these BVOCs. The chemistry is tricky. There's a lot of different kinds of compounds in the atmosphere already. So the balance of those compounds can ultimately change the effect. It depends like what those things are interacting with. If it's a dirty atmosphere, dirty usually means there's like a bunch of nitrogen in the atmosphere. That could be different. So it's more nuanced than what I presented. What I presented was the result of sort of the only study we know that put in all of the global, the forests of the entire globe. But I think if you drill down to one place, it depends how dirty the atmosphere is, what the dynamics are there, what the temperature regime is, how much incoming solar radiation is. If they already had a bunch of clouds, it's not going to have a big effect. So there is a lot of different effects. I'd say mostly we don't know. So if you're interested in sort of what should I work on in the tropics, BVOCs is one, and clouds in general would be another.
Maybe time for one quick question. I have a quick question, and maybe it's a bit complex, but if you have you present these results to policymakers, governments, or decision makers, and is there some reaction of getting scared by the transformations in the climate system that can result from deforestation?
I have mostly informed people who would inform the policymakers. But I have talked to the public. So I don't know if the public is considered a policymaker, like we vote. So in effect, we are the policymakers, but we don't actually have we don't have the pen. When I talk to the public is shocked at the idea that you can deforest and change rainfall, because it's not crazy to think that, the way deforestation happens is usually we deforest to create agricultural areas or commodities. So it's like the purpose of deforestation is to get agriculture going. And then the potential effect of too much deforestation is bad effects on rainfall, which then inhibits agriculture. So people make that connection quite quickly that like, wow, you should really maintain forests, because if you don't, your agricultural sector will suffer. I think the place that I also feel like we should push with policymakers and with the public is with the health effects. Like here we are, we're talking about nature, but the cities nearby, giant swaths of forest, especially in the tropics, those cities, they need those forests nearby. So if we think about human health, or if we think about ecosystem health and agriculture, and the fact that some of these tropical economies are very much agriculture driven, we should care, we should conserve. It's not just, we're not doing it for free or because it's a good thing to do, because it's just nice. We're doing it for survival. We're doing it for economic reasons. So I think there's a strong case to be made for public health and economic viability that we need to maintain forests in the tropics.
Thank you so much, Deborah. We're going to move on to the next speaker, and we have someone in person here, Grizelle. Thank you so much for coming all the way from Puerto Rico. And the floor is yours.
So it's great that Deborah was able to present a global perspective of tropical forests. I'll be presenting or zooming into the Caribbean region and using Puerto Rico as a case study. And I'll start describing the geography. Puerto Rico, it's an archipelago of about 143 islands, islets, and cays, and covers around an area of 900,000 hectares, and a little bit over 3 million people inhabit 3 of its islands. 16% of the area is protected, and the largest tract is in northeastern Puerto Rico by the El Yunque National Forest, also known like the Luquillo Experimental Forest, in recognition of the amount of scientific information that's coming from this forest. Puerto Rico has over 60% of the land covered by forest. That is the highest for the Greater Antilles and also the Greater Caribbean area. And it has the highest density of plant species per area of the Greater Antilles. The below grants are just as diverse. 10 of the 12 soil orders you can find in the main island has used in the classification of the US system. So within a very short amount of distance, 12 kilometers inland, you can find sharp gradients in elevation, precipitation, and temperature, where you can find fresh or salt water swamps or dry forests in proximity, very close to alpine or cloud forests. So it's not surprising that global climate change models provide very little horizontal resolution for Caribbean islands that have very steep climatic gradients. Downscale statistical modeling for the region projects forward temperatures in the range of 1 to 5 degrees Celsius, depending on the climate change scenario. And the projections are that land surfaces will be warming faster than the ocean, the topography creating variation in this warming, with the interior warming more than the coast. And in terms of the precipitation projections, there will be projected seasonal changes for overall drier conditions. Of course, this situation of higher temperature and drier conditions, it's predicted to affect the water availability at the surface, subsurface, and groundwater levels. There will be changes in the cloud-based height that has been observed using ceilometers located in the site, and neotropical cloud forests may contract and dry given these declines in cloud immersion. With increased temperature in the water, we know that the frequency and intensity of hurricanes will increase. And then the effects of these extreme events not only happen in the terrestrial environment, but this interconnectedness also occurs with the marine. There are direct effects of the extreme events on the marine environment, but there's also more sedimentation, bioerosion that hits the coral reefs, affecting ecosystem services like fisheries and shoreline protection, like we're seeing diminishing in Puerto Rico, that will affect the livelihood, the nutrition of people, as well as the property and businesses. So to look at the effects of these hurricanes, these are the main effects of hurricanes: the debris deposition on the opening of the canopy, as well as the intense frequency. Scientists in Puerto Rico associated with the Luquillo long-term ecological research site set up an experiment to simulate these hurricanes. And what we have seen is a cascade of events where when you open the canopy, you increase solar radiation, you decrease litter fall and transpiration. And even though throughflow increases because of the increase in solar radiation, the moisture in the litter decreases, but acts as a buffer it maintains the moisture in the soil. That triggers a cascade of events, a change in the biota. For example, decreases in the frogs, changes in the fungi from macro to micro fungi, and the animals that are so important in the decay process in this forest. So the combination, that fragmentation of the organic matter decreases, and due to decomposition, nutrient cycling decreases. However, with that increase in the canopy, the pioneer species get established. They usually have high nitrogen and phosphorus, and that increases herbivory, and that frass then gets into the system and can increase litter decomposition. The question is, what will happen to tropical forests under the combined effects of the increased climate regime, temperature, and the disturbance regime? And for that, we have set up a warming experiment where we have increased 4 degrees Celsius above ambient temperature. And what we observed when the experiment was established in 2000, there was no significant effect of warming and the controls. However, that completely changes after the 2017 hurricane season, where we see that after hurricane disturbance, then, for example, an ecosystem process or the fine root production then decrease in the warmer that relative to the control. So it is interesting. We know from modeling exercises that warming tropical forests might increase the sites in the LFD, of course, dynamic versus the Bisley watershed, another site where you have the Brestoia montana, but compared to Slovenia verteriana, which is a denser wood species, you see when you have that species, then the mortality is higher compared to the palm. And so what we are seeing that these functional types of palm might actually be driving and changing the ecosystem. So I'll leave it there.
Thank you so much for the great talk. We have time for a few questions.
Thank you. That was a great talk. It's really interesting to drill down on one site and hear about the dynamics there. And I'm really interested about, you're talking about the palm species and how it recovers from hurricanes and sort of what the, and so I'm curious about, in particular, about carbon storage, given that it's palm, not a real tree, and how the consequences of that under increased hurricane frequency, and if there's predictions of how that would increase in abundance and how might that affect the carbon storage capacity of these forests.
So what has been observed at this slide, when there is like a infrequent hurricane or a hurricane since no hurricane for a long period of time, is that above ground biomass might increase as well as diversity to a certain point. But it's when we get the intense frequent hurricanes where that dynamic might change. And what we're observing is that the palms are doing much better than some of the other functional types, but there is a trade-off. For example, when there is a hurricane and you might, for example, release some of the medium-sized trees, then the larger size that are surviving might take off and dominate the canopy and then be accumulating, sequestering carbon. But if we get to a tipping point where then the palm is the functional type that might be seen doing better with the more frequent hurricanes, certainly that will change.
Have time for another question? Yeah. Hi, my name is Nick Brokaw. I've been studying three-dimensional forest structure in Puerto Rico for 30 years, and I think another consideration when it comes to carbon is that an increased frequency of very strong hurricanes will eliminate the larger trees and just reduce the height of the canopy. And the big trees, and as you know, the big trees are the ones that have the preponderance of biomass. So that's another thing that may well happen. I have another question about the resilience of the forest, right? We're talking about some of the feedbacks, and there's some research showing that feedbacks between climate and vegetation may lead to collapse of ecosystems, at least in theory. And I was wondering if with the hurricanes, there are processes that are triggered related to nutrients or dynamics that can really degrade the system over the long run. Maybe talk a bit about nutrient dynamics after a big hurricane.
So this is an area kind of into the unknown. I think after the 2017 hurricane season has put us in really a good track to look at that interaction effects of the increased temperature and the frequency of the hurricanes. There has been some recent modeling efforts for the area, and I showed some of the initial analysis where there seems to be an increase of carbon sequestration with scenarios of increased temperature and CO2, but to a point, because with the increased frequency, the two dynamics, one like Nick Brokaw mentioned, there is a significant effect on the hurricanes on the height of the trees and the canopy. For example, we have been working in collaboration with NASA, and we were able to do some lighter flights, and we know that at least 30% of the height, the structure of the forest decreases after the passage of the hurricane. So that's a significant consideration. And then there is changes, of course, in the nutrient cycling, because you get that amount of litter that is fresh litter that has high nutrient concentration, but that gets flushed through the system quite quickly. What we then see is a process of lignification, decreased decomposition, and then it's after you start seeing the recovery of other species like the pioneer species and the increase in herbivory that the systems gets into the recycling of the nutrients. It's been very interesting to look at the interaction, for example, the micro fungi and litter invertebrates, and how you see a complete transformation in that community to animals that can pierce the microfungal and then affect the lignification and nutrient process, which is very important in terms of nitrogen and phosphorus in the system.
Thank you. This is super interesting. Thank you so much. Amazing talk. We're moving to our next speaker. Now from two from England, and the first one of them is Yadvinder Malhi. We'll be talking about forest resilience. Yadvinder, you have the power to share the screen, I think.
Okay. Hi there. Good afternoon. Can you hear me okay?
Yes.
Great. Okay, thanks for inviting me to this seminar. It's been great to hear the other talks. And I'm going to be talking about another process in the tropics, which is around ecological degradation. And so, when we when we think of forests, we often, a lot of us work in primary tropical forests, these majestic forests with huge biomass, lots of carbon stocks. They're also just magnificent to see at, and many of us would often confess to having a bias towards those forests. But what I'm going to focus on in this talk is this sort of landscapes. These are heavily logged landscapes, in this case in Malaysia, where you've lost a lot of the biomass, a lot of the structure, and these are labeled degraded forests. And sometimes that labeling of forests as degradation can be helpful to their protection because they may be encouraging restoration of those forests or funding through mechanisms like REDD+. But other times it can be unhelpful because these forests can be labeled as ruined forests in some ways of lower ecological value and therefore more appropriate for conversion to agriculture. And so often you might see companies or governments saying, well, we're not going to deforest old growth forests, we're going to focus our agricultural expansion on these degraded lands only. So what I want to do in this talk is question this idea of degradation. This is another sort of feedback. This is essentially a social physical feedback where degradation of some form can accelerate further conversion of forests through that labeling, through that process of designating something as less than pristine, as somehow of lower ecological quality. So I'm going to interrogate that a little bit in this talk. And for those particular forests, if we look at them, these are LiDAR scans, airborne LiDAR scans of these forests in Malaysia. On the left, you've got old growth tropical forests and a magnificent forest, some 60 meters tall. These Bornean rainforests are amongst the most magnificent forests you can find anywhere in the tropics. And on the right, you've got these forests after several rounds of succession, and structurally, they're undoubtedly degraded. You see average canopy heights around 20 meters. A lot of the richness of structure that you get in the old growth forest has gone. So structurally and in terms of biomass, they are degraded. But how are these forests in terms of ecological function? And what I want to do here is apply a lens that hasn't been used so much in thinking about these questions, which is the lens of ecological energetics, about how much energy flows through these forests and cascades, in particular from the plants through to higher trophic levels. And energy is a useful way to think about this because it's a physically meaningful unit that can be consistently applied across taxa. And it reflects something real in the world. It isn't some sort of made-up index, but it reflects the metabolic function and activity. A physicist defines energy as the ability to do work. So whether in any organism or species, it's the ability of that organism to do work. And the case study I'm going to look at is in northeastern Borneo, in the state of Sabah, and comparing intensely logged forests in the SAFE project, which is the stability of altered forest ecosystems, a project that's been running for 10 years, comparing that with intact forests in the Malhi Basin and in Danam Valley and other parts of Sabah. And so if you look at biomass in these forests, these reflect what I said in my opening slides. There's massive carbon stocks and biomass in old growth forests, and it diminishes hugely in the logged forest, but diminishes even further if you go to oil palm plantation. If you look in terms of productivity, you don't see as much change. You see slightly higher productivity, if anything, in the logged forest than in the old growth forest, and even higher productivity in the oil palm plantation. And so what happens in that logged forest is that we find relatively intact stands of log forests actually have significantly higher productivity than the old growth forest as trees race towards the light and prioritize productivity. But there are other areas that are logging platforms that are heavily degraded that offset that. So overall, there's only a slight difference in productivity in the rate of production of biomass. So the next question is, how much of this productivity ends up flowing through key vertebrates? In this case, I'm going to focus on birds and mammals because they're the best studied, best understood taxa. But in an ideal situation, we'd also look at invertebrates and other components and get a full ecosystem understanding. And I think this is particularly interesting because we can think of the energy flow through particular gills as a proxy for key ecosystem services. So how much energy flows through seed dispersers, for example, or nutrient cyclers or predators. So we can look at that as ecosystem services or in terms of trophic pressure on ecosystems. And I haven't got time to go into the methodological details, but what this involved is a huge amount of sampling on the ground, an incredible range of mammal sampling, camera traps, small traps, harp traps for bats, independent studies on some species like orangutans and elephants, and lots of point counts of birds and estimates for some of the larger, more trickier species. But an incredibly detailed survey of every population density of every mammal species and every bird species to be able to do this analysis. And so here are the results. So surprise number one, before doing this work, my expectation was that the energy flow in the logged forest would perhaps hold up to what you have in the old growth forest before perhaps collapsing in the oil palm. And what we found instead was a surge of energy flow in birds and mammals, around 2.5 times more flowing through birds and mammals in the logged forest than in the old growth forest. So this reflects higher population densities of birds and mammals overall in the logged forest compared to the old growth forest. And then in the oil palm, in the birds, it drops back to old growth forest levels. In the mammals, it collapses more severely to much less in the oil palm than in the mammals. The other thing is actually that what's striking is twice as much energy flows through birds than through mammals. So these are really bird-dominated systems energetically, which is not what I expected. The bird biomass is smaller than mammal biomass, but birds, because they're smaller, they have much more energy, much higher metabolic rates, so much more energy flowing through those birds. And this is another way of looking at it, where the circle represents the amount of energy flowing through a particular gill. So the other thing that's really striking here is certain gills dominate. Arboreal insectivorous birds are a major component of energy flow through these forest systems. Terrestrial herbivores are quite minor in the old growth forest, but they grow in significance once you get into the logged forest. They do really well in the logged forest, things like deer and elephants, for example. And then they collapse in the oil palm. But the other thing is that this could be driven by a few generalists taking over. So, maybe there's energy flow there, but ecologically there is degradation if you're losing species and just getting a few generalists taking over. But when we looked at this, either in terms of species count, the S numbers you can see there, or in something we call the energetic Shannon-Weaver index, which looks at how energy flow was distributed across species, we see that species diversity is maintained, and the amount of energy flowing to different species is maintained in the logged forest. So this isn't just the case of a few generalists taking over and dominating the energy flow. It's the energy pathways are diverse and therefore resilient as they are in the old growth forest. And that doesn't carry on once you get to the oil palm. There you see species numbers dropping. You see the Shannon-Weaver index collapsing as well. So you lose that diversity once you get into the oil palm. And so this particular study site is one that isn't hunted at all. So is it possible that one of the features often associated with logging is access roads and more hunting? So does hunting undermine this story in the case of most logged forests? So we did some simulations of hunting. So we looked at whether if there was targeted hunting where particularly valuable species are taken out by poachers, or whether there's indiscriminate hunting where you've got snags that take a significant number of species out. And we simulated that all the 50% collapse of the targeted species or the indiscriminate hunted species as well, to see how that would affect. And what we found is actually, if you do have 50% collapse of all those huntable species, then you get back to energy levels similar to the old growth forest, but not less than the old growth forest. So, and for birds and for mammals, you don't even do that. So the effect isn't offset unless you have extremely high degrees of hunting. For example, like 90% of the population taken out by hunting. So hunting, you have to have very high levels of hunting to offset this effect. And so another possibility is that you could have turnover in species. So the old growth specialist species drop out and you have all of these disturbance specialists coming in and taking over. That would be some form of ecological degradation. But actually, this shows species by species what we see are the winners and losers. And I've only shown here the top 20 winners and the bottom 20 losers. There's a whole range of species in between. And what you can see here is that from the fact that the red bars, even at number 20, are very positive, that if you did the whole chart, there'd be loads of positives coming down before you get to the negatives. So most old growth species do better in population densities in the logged forest. And there's only a couple of species, the brown spiny rat and the mouse deer, that do significantly worse in the logged forest. So we're not seeing the old growth specialist species dropping out. We're seeing most species doing better in the logged forest. And so what's going on here? I think the dominant factor is bottom-up factors, that as you're moving to the logged forest, plant communities are shifting to early successional, more palatable species, and this increases consumption by herbivores, but particularly by arthropod herbivores that boost the insect populations, and they boost the insectivorous populations. Also, there are other factors. There's more vegetation near the ground, so the large herbivores benefit from that, ground-dwelling herbivores and omnivores. And overall, the forest becomes less chemically defended in that very conservative old growth phase and becomes more palatable, more edible, more salad-like, using a phrase that Lizzie Coley sometimes uses. But there also could be some top-down factors around protection from predation. But actually, overall, judging by the density of predators, we think actually it's the bottom-up factors that dominate here. So to conclude, firstly, we should say that old growth forests have immense value. So none of this is to argue that we should log more old growth forests to somehow make them tastier and more palatable and support populations. But what we're trying to perhaps argue here is we should look again at this concept of degradation that's used quite widely, but almost always is used in the concept of, in the framing of biomass or carbon stocks. Overall, that's the carbonization of our debate around ecology is one feature that we see a lot. But actually, when we take a more holistic view of ecological function, we can see some surprises that, and many logged forests are not only ecologically vibrant, in many cases, they may be even more ecologically vibrant than old growth forests because of this releasing of this conservative system into a more dynamic and ecologically active system. So, thank you.
Thank you, Yadvinder, for the somehow provocative talk. We have time for one question, maybe two, a quick one.
Thank you so much. That was a really awesome talk and makes me think a lot because I also work in sort of degraded forests that also have high diversity. So I'm really curious, what are some of the responses that you have when you show these results or when you talk to people who work in these degraded forests? Do you have people sort of get excited that yes, now other scientists are seeing the value of these degraded forests, or have you seen sort of pushback of being like, no, we don't want this, degraded forests are actually good too message? Can you tell a little bit more about that, please?
Yeah, that's a very interesting question. And I had been slightly fearful when this paper came out that there'd be a little bit of a backlash, say, from people very focused on protecting intact forests and old growth forests. And actually there hasn't been. And if anything, I've been surprised with the number of responses that have been a bit like yours, that people who work in secondary forests and others and degraded and logged forests and say, actually, yeah, we see this in our data too, that often there seems to be higher abundances of a lot of old growth forest species there overall. And I've seen this in my data and I didn't really know what to make of it. So it didn't really fit into the framing of what the questions I was asking us. So that these sort of data often sit on shelves and haven't been but they're all seen as individual anecdotal data from an individual site. But I've been, I suppose, pleased that to the extent that I've seen a number of studies from around the world, whether there's grade data or informal reports, saying actually this is exactly what we find in our forests. And because we haven't framed our framing of protection of forests often around the value of these degraded forests, this stuff hasn't come into the literature as much as it should do, perhaps.
Any other question? Yeah. If you have more questions, we'll have time afterwards also.
So, thank you for the presentation. But just to let you know, global warming has become, in fact, a challenge to the world entirely. So from your own context of presentation, because the first presentation shows some graphics comparing what is happening in Africa together with also other continents as well. And on your own presentation, you have shown the impact of the energy impact as regards to degradation. So considering Africa as a continent, this is where energy challenge is a very serious case, and there's no energy challenge, and the people there survive through the biomass, wood to fuel, energy source, and as a result, regards to that, they have contributed a lot to degradation. So I want to know from your own context, what have you been doing to reach out to build partnership to other sister agencies that is working mainly in Africa in order to reduce the impact of the deforestation going on in Africa? Thank you.
Okay. Because of sound quality, I think I was only getting about 70% of that, but I think I understood it. So in terms of the effects, I think what part of what we see here, there is a difference between the climate story and the biodiversity story. So undoubtedly, forest degradation leads to carbon emissions, but in terms of biodiversity, used forests, you can call them logged forests, but I think other ways that people use forests, whether for firewood and other things, doesn't necessarily lead to biodiversity degradation itself, and in many ways can, so I think this distinction between unused and used forests in terms of ecological value can be unhelpful. In terms of getting this message across, this particular one I think is a new enough message that I confess that we haven't really dealt with. This isn't a discovery building upon years of work or something. This is something that's relatively new in our thinking. So I think how we appropriately work with this message, getting the messages that are positive across, but also not confusing that with a negative message of saying, well, it's fine to log, we're just making these forests healthier if we go and log these intact forests. I think requires some careful thought, but I think that there are important messages and discussions to be had in there.
I'm going to give you one more question because Yadvinder made it earlier. Yeah.
Hi, thank you so much. Yeah, I was sort of thinking about, I think kind of our conventional knowledge on conserving old growth forests is that, you create sort of an absolute reserve and can, isolate humans completely. And it seems to me like this is sort of evidence that humans can be a little bit more integrated into forests, potentially without seeing such dire consequences. Do you think this is evidence that like the divide between conservation and human use is less black and white, and maybe a little bit more gray? I'm curious to hear your thoughts on that.
Yes, so I think this particular study is around logged forests, but I think it applies to many human used forests. And I think there is, I think it does argue against this notion of pristineness being the ideal concept of the state of nature, that somehow nature without people is superior in some senses to nature with people. And obviously, every context depends on the specifics of how people are changing and affecting that system. But and so there are always nuances in any particular context. But I think it does perhaps provide one way of thinking about that and seeing what the actual ecology says, rather than going in with preordained mindsets of what the hierarchy, the change of value with pristine at the top and human altered underneath. I think it's valuable to actually just look at systems and say, what's the ecology doing here, and then come to decisions about value and how the ecological value of systems, rather than predefining that in some sort of arbitrary idealistic sense of value.
I've been told to jump in. I want to just pile on. I think you're right. This works in the climate system too. A degraded forest interacts with the incoming solar radiation in a better way than an oil palm plantation, in a better way than a soy farm. So like forests are good in many ways and in many states.
Thank you so much. So we're gonna move on to the next presentation that you present the other end of the spectrum. And maybe just to prove that Yadvinder is wrong, right? Simon, I think this is what he told me. Simon, we cannot see you right now. Or hear you.
Hello, can you hear me now?
We can hear you and we can see you. Yeah, thank you.
Great. And can you see the slides?
Yes, we can see the slide. A beautiful photo.
Super, super. Thanks very much for the opportunity to speak. And while I definitely recognize that forests are more than sticks of carbon, and the value of logged over forest, I'm going to talk about carbon and I'm going to talk about intact forests. And I'm going to talk about a lot of field work and using field work to get at some interactions and feedbacks with the Earth system in tropical forests that we can't yet do from space, from satellites. So I want to talk about some recent results on the intact tropical forest carbon sink, which Deborah mentioned in the beginning. And we know that about 45% of the emissions of carbon dioxide that we put into the atmosphere stay in the atmosphere, and the rest goes into the land surface and the oceans, around 20–25% going into the land surface somewhere. So if that land sink doesn't keep up proportionately with the increase in emissions, then the climate crisis will get proportionately worse. So I think it's important to think about that question. And then second, at the very end of last year, we published a new paper on a tipping point in the central Congo basin, which I wanted to touch on. So in terms of the intact forest carbon sink, we have been a huge collaborative effort to measure trees on the ground. So we usually have a 1 hectare plot and recensus every tree, measure its diameter, identify the species, measure the height, return over time, and then we can calculate how much carbon is stored, and then how much carbon is stored over time, and we can tell whether we can estimate whether this forest is taking carbon out of the atmosphere and storing it in the live biomass, or giving it up and giving carbon to the atmosphere. And we have done that and put them all into the same database, so we can have the same analysis chain over huge numbers of trees being monitored across the tropics, with a vast number of researchers associated with these plots, some of them running for over 40 years of change data across the 3 continents. And if we put these together for the Amazon, all the plots in the Amazon that were monitored at that time is where that black line is, and then the uncertainty band is the gray, and the darker gray shows that more plots were monitored at that point in time. And what we see is this line is above 0. So these forests are getting bigger over time. They're taking carbon out of the atmosphere on average, but there's been a long-term decline in the carbon sink. So this has not been keeping pace with the increase in emissions from fossil fuel use. So this feedback is changing in the tropics. And then we've added plots from across Africa, mostly across the Congo basin. And we show that in Africa, again, the line is above 0. So these forests on average are getting bigger and taking carbon out of the atmosphere in the absence of any direct human impacts. But it's been pretty steady over the 90s and 2000s. So again, this carbon sink appears to have saturated and is not keeping pace with the increase in emissions over those 2 decades. And what we see if we put this all together is that we've got both a declining per unit area forest sink and a declining area of tropical forest. And then over these 2 decades, we've lost around half of that sink capacity. So there's a really substantial change from the loss of forest and the lower rates of uptake over time. And of course, given that globally, we know that the same fraction of carbon dioxide is staying in the atmosphere, then somewhere else in the Earth system has been increasing in carbon uptake more than proportionately to account for this substantial decline in intact tropical forests. So there's a more important shift in the whole Earth system, global cycling of carbon. Now, the next point I want to go on to is in the Central Congo Basin, where I spent a lot of time and done a lot of work. My colleagues in the picture and others. And I had an idea a few years ago, maybe a decade ago actually, that this huge wetland the size of Germany in the Central Congo Basin, maybe it had peat underneath. So we spent years going around and sampling for peat and then mapping it and showing that it actually is the world's largest tropical peatland. And this is what it looks like. And it's actually quite a short forest, and a bit, as Yadvinder was saying about these energetics, you think there's the highest densities of lowland gorillas anywhere in the world in this peat swamp forest. And there are incredible densities of elephants. And everything's more in reach to these mammals because this forest is quite short and relatively open. And there are very few very big trees. So I think there's something that kind of fits there with what Yadvinder was discussing. And peat is semi-decomposed plant matter. It's very high carbon stocks. We estimate in the peat in the region, there's 29 billion tons of carbon. That's the equivalent of 3 years worth of fossil fuels. So an enormous stock of carbon sitting there in the Central Congo Basin in these seasonally flooded forests. But when we had a huge surprise, when we took one of these cores that's 6 meters deep and radiocarbon dated it to see how old it was. And what we saw is that from around 20,000 years ago until around 7,000 years ago, we get rapid peat accumulation. And then almost nothing in that brown band, almost no accumulation of peat for around 5,000 years until 2,000 years ago. And then a rapid increase. So what's going on in this period of around 5,000 years where we have almost no peat accumulation? And when we analyze this peat, we see that it's super decomposed, highly decomposed in that brown band, where there's very little accumulation. And what happened at that time is that it got drier. And we know that because in the peat also preserved are the waxes on leaves that are preserved in the peat, and we can analyze them for the isotopes of hydrogen to then estimate what the rainfall was like when that leaf wax was produced. And what we see is that it got wetter from around 10, 12,000 years ago until maybe 5,000 or 6,000 years ago. And then it got much drier. And that lowered the water table, exposed the peat to oxidation, and peat and carbon was lost to the atmosphere. And in this single core, we estimate that between 2 and 4 meters of peat was lost to the atmosphere during that time. And the degradation of the peat was so high that it removed peat that was older than when the beginning of the drying happened. So the water table was low enough to expose really old peat to be oxidized and go to the atmosphere. Now, how that relates to the present day, well, before I get to that, but then the climate stopped getting any drier, and feedbacks in the peatland allow it to start to re-wet and for peat accumulation to increase and start up again and recover. And how that relates to now is that we now know that these peatlands, unlike other tropical peatlands, are very close to a drought threshold where that carbon can be released. And there's some evidence over the last 2 decades that one of the 2 dry seasons in Central Africa has been getting longer. And some climate models, but not all, show increased drought frequency going forward this century. So we're in a situation where this 29 billion tons of carbon that's locked in the peat is potentially very vulnerable to climate change coming down the line, because it's really close to that point. But what we don't know, why you need investment in science in Central Africa, is that we don't know whether it's really going to get drier, and that this peat could be, some of this peat could be oxidized and going into the atmosphere and accelerating climate change rather than slowing it down as it has done in the recent past. And I'll leave it there and take any questions. Thank you.
Thank you so much, Simon, for this great talk. We have time for 2 questions and then we open for everyone.
Thanks, Simon. That was really fascinating. I have a quick question about if you think this process depends more on annual rainfall or on dry season severity and length, and how those 2 are predicted to change over time in this region? And then more generally, if I'm going to take my second question, how generally do you think this may impact every tropical forest region? And so you think as well,
I couldn't hear the second question, but I could hear the first one. So why don't I answer it while someone passes the microphone to someone so I can hear it? So the first one, I think it's about the dry season length. It's once the peat is dries out, then it's being oxidized to the atmosphere. So some of that is happening every year, I think, but the net over the year is still that the decomposition process of the new material that goes in is not going to completion, and you're having this residual amount left that's then incorporated into the peat. So it's the duration and the severity of the dry season, rather than the overall annual rainfall that counts. And dry seasons are predicted in some models to be more intense this century. There was a second part to the question, but I just couldn't hear it.
I have another question.
So considering the outcomes of your studies, especially in Congo Basin, do you have any recommendations that you have made, maybe to the policymakers or to the country to, guide, accelerate any support to, reduce that impact that is going on the Congo Basin?
Thanks very much for the question. In terms of the peatlands, after the initial, in inverted commas, discovery of such a large area of peatland, then the Democratic Republic of Congo government and the Republic of Congo government signed the Brazzaville Declaration to commit to more investigation and to sustainably manage the peatlands. And more recently in DRC, the government has set up a peatland management unit which is taking advice from scientists about how to manage the peatlands. And there are some, there's a UN project to set up monitoring system and management plans for the peatlands. So I think in that sense, it's been reasonably positive, but not everything. The DRC government, on the other hand, announced last year that they would allow oil exploration over around 11 million hectares of tropical forest in the Congo Basin in DRC, and we overlaid their maps with ours, and around 1 million hectares of peatland. So, you know, there's good things happening, but the peatlands are pretty intact. I think that's the most important thing to say. They are used by local people, and their main use, or the main benefit of them, is that they're essentially giant fish farms. The young fish of many species that are the backbone of the local economy, because many people are fisher folk, spawn and grow in the peatlands and then migrate out when they're out of the juvenile phase. So they're very important to the local economy and local people. People have a kind of different relationship to them than to terra firma forests elsewhere in the Congo Basin, from what I've seen.
Thank you so much. Simon, we are going to open for questions for everyone. Maybe you can put everyone back on the Zoom here. And the first question is from the chat, and it's for Deborah. It is about, give me a number for the climatic threshold associated with deforestation. Is there a certain amount of deforestation that leads to abrupt changes in climate?
I did answer this. I don't know if anyone was watching, so I'll answer it again. The place where I think this has been studied best is in the Amazon. And in the Amazon, they think it could be a threshold between 20 and 30% deforestation would lead to a shift in vegetation where the big giant forests are replaced by savanna type vegetation. You can imagine the chunk of loss of biomass carbon. You can imagine the chunk of failure to send water into the atmosphere. Like, it would be a radical change if that were to happen, with just cascading effects, feedbacks all around the world, I would say. So 20 to 30% is a number that's thrown out there. I really respect the people who do that work. I think it's still debated whether or not there's like a cliff or it's more like a slow falling over the edge of a hill. I don't know, but it certainly would be bad. In the other two zones, like in Central Africa and in Southeast Asia, I don't think there's been any work on it. And here's what I would say. In Southeast Asia, there's that whole massive ocean. So I think that buffers whatever's going on. There's plenty to worry about just with plain old loss without a giant feedback that triggers further loss. The one place where that wouldn't be the case, I'd say, is in the peat. So the peat forests of Indonesia, there could be some bad triggering that would result in really catastrophic losses of the rest of the peat. In Central Africa, they haven't studied it, but my understanding about the way deforestation works in Central Africa is that it's not like Brazil, where they have giant soy farms and giant cattle ranches. You could correct me if I'm wrong, Simon, but like, I think it's smaller, which is a different thing, at least for the climate system. At small scales, deforestation is not as bad. Then it gets worse as you get bigger. So, you know, I don't know that we know about a threshold in Central Africa, and I would doubt there would be one in Asia, but I think it's possible there's one in Amazonia.
Thank you, Deborah. Any questions from the audience here?
So, Yadvinder, I just had a question. Well, maybe two questions. The first one is, how much of a continuum do you think this is? Like, going from a pristine or natural forest to a log forest, do you think that the effects on this in the energetics of the forest is it like a continuum of like do you understand the question? Like, is it always gonna go in a linear kind of pattern? And the second question is, how do you go about this message of like people not going towards, okay, let's just log the forest because it's actually gonna be beneficial for the energetics or like animal abundance and diversity?
Yadvinder?
Mute.
Old mistake. I think I'll answer the first one, which is the easier question. I think the continue. So what we did do in the supplementary material of that paper is compare. We have some sites which were moderately logged, 3 or 4 trunks per hectare, which is more like typical logging in Amazonia or the Congo Basin, and some sites that were heavily logged, multiple rounds of logging with about 40 or 50 trees taken out, which is much more like the most intense Southeast Asian dipterocarp logging, and those, you know, those very heavy logged forests. They're ugly. They're not for tropical forest aesthetic. They're not pretty forests, I wouldn't say. But what we did find is that the energetics continued to rise even in the very heavy logged forest compared to the lightly logged forest. So it wasn't as if there was a sudden step change and a drop down. There seemed to be a slope to quite heavy degrees of logging, and only when you go to really extreme logging platforms and then ultimately to conversion, where you're losing the soil, you're losing the basic bedrock of the ecosystem, then you start seeing collapse in the energetics. On the second question about how do I feel, I'm certainly, you know, this is one of my concerns that this could be taken in a way of just saying, well, actually, it's fine to just commercially log or large extents of intact forest, and it's fine, it's good for the forest overall, which is not the message for lots of reasons, including the things that we don't. There's lots of very specialist species beyond the birds and the mammals that we don't understand, as well as the climate and other functions and the carbon function that Simon was describing. So I think it's important to really focus on what we're saying is about the value of the logged forest rather than the lack of value of the pristine forest in terms of the emphasis and the messaging. And so far, at least, I've been pleased that that's that latter message, the first message, the value of the logged forest, that's been coming through in whatever media coverage we've had rather than the other one. But you never know. There's always someone around there to twist the emphasis. So you have to keep alert to that.
Simon, you want to chime in?
Same with me.
Yeah, I mean, just a word of caution, I think. The places where biologists study logged tropical forests are places where there's a very good relationship with the people doing the logging. Either they're experimental or they're semi-experimental, or they're the bit that the company knows that everyone's looking at. So the logging is like better, less destructive, and the controls on hunting and other access issues but particularly hunting are high. And when you go to other places, like, you know, I've been to lots of different logging places, often looking for to remeasure plots that someone's abandoned a long time ago. And like, I see that I could get 10 or 15 years data time series if I can find this plot that's now in somebody's logging concession. And those places are a catastrophe. And you don't see any animals in there. So I think we need to be very careful to separate kind of biologically intact logged forest and biologically intact other impacts from direct impacts from humans, rather than saying all log forest is kind of, it's fine for wildlife. Even though, like, when Yadvinder told me the results, I wasn't surprised. It makes, you know, it makes sense, ecological theory. It makes sense from what we all kind of know from studying these things. And you can go to some log forest in, say, Gabon, and you just see everything because it's really well controlled. And other places you see nothing because there's barely any controls.
Yadvinder, before you defend yourself, wait, you don't defend yourself. Let me defend you. Here you go. I just want to tell a story about walking in the other part of Borneo in West Kalimantan in trashed logged forest, trashed. not well managed. No one was studying them. And walking through those forests to get to my sites, which were in shifting cultivation, and kind of shedding a tear as I walked through these forests to get to my sites, thinking this is so sad because I knew what was there before. And then going back 15 years later and trying to get to that village and riding a motorcycle through oil palm. And I'll tell you, I rued the day that I thought I was so sad about logging. I was like, wow, logging is great. Logging looks so much better than this. And so I'm not going to say, let's log, but let's say we log, and we should keep logging. We should not convert. What happens in at least West Kalimantan, in the southern part of Borneo, it's like a process to conversion. It is not logging, it's converting. So I just think, yeah, now you can defend yourself.
I would like to add to that.
Just to answer the
reply. And I think this has been an old debate on forest management of natural forests in the tropics and how sustainable can be logging on that forest. And I think from an ecological point of view, is good to have that logging. And even you have all these studies on forestry growth in the Amazon showing the ecological value. Miguel Pinero did these studies in the Peruvian Amazon also showing the important contribution of those forests for supplying timber for construction in the cities, etc. But I think what I would like to add is that we have to see this problem also from an economic standpoint. It's because when you log all these more valuable species, and we have been seeing this over and over in the tropics, is that those forests have lost value and the transaction cost of converting those forests to other uses to agriculture has been very high. That once that you have the first logging, those forests are going to be converted. And we have been seeing even with forest concessionaires, they are not going to wait for the second harvest. They don't wait for the 20 years to that forest to those species to regrow. So that has both economic value. So, and that has been the major problem with the pressures on conversion. But also it has been interesting to see this last paper from Plinus and Jack Patzel. They were saying that even 20-year cycle for those forests may not be sustainable. And for some species, you have to wait for 100 years, from an economic standpoint, for that forest to be valuable and to do the logging. So I think we have to see the problem from an ecological and from an economic perspective as well.
Yeah, just to respond, I think that's a particular definition of sustainability, which is how long can timber extraction of those valuable species be maintained, which is only one metric of sustainability, I think, to think about. And I think, you know, we when you say that forests lose economic value, the economic value implicit in that forest is that they potentially be logged in the future. It's the timber value that you're using as your metric of economic value there as well, rather than perhaps ecosystem services or other things. So, you know, so that implicit in that valuation of a forest is the fact that it's potentially loggable at some stage in the future. And the other point, I think, just to say on these particular forests, yeah, if you saw these forests that we were working in, Simon, you definitely put them in the very trashed category. These were not pleasantly selectively logged by sensitive operators at all. So I can take the point about them not being hunted for a variety of reasons, but and I think that on the hunting point, I think it is clear that we need more similar analyses in other places to see the degree to which our hunting offsets that. Sometimes hunting takes out the most visible things like the big mammals, but often the birds, for example, are things that are important for so many ecological functions are not so affected to the same degree by the hunting. We may not see the charismatic megafauna, but other things can still be there.
So I would like to shift a little bit to go back to Puerto Rico with Grizelle, and you have a system that is being hammered really hard every couple of decades, and presumably the forests have some adaptations to cope with the hurricanes. What is different now, you think, in terms of the impacts and moving forward? So are we surpassing the resilience of the system, you think, with the new regime of hurricanes in the region, or are there other pressing issues?
Well, I think the experience that we have observed for the hurricane is that the tropical forests are quite resilient to these disturbing events. And if you receive these extreme events in a frequency that allows for the recovery of the system, it actually beneficial. And there's some studies that have shown that this damage of forests can incorporate more carbon as compared to the impact. So there's also some trade-offs similar to what the colleagues have been mentioning here for degraded sites. But of course, there is a trade-off there. Where is the point where we might be reaching to that tipping point? And that is what we don't know. We used to think that these hurricane events were going to pass through the area on a rate of 50 or 60 years, but the reason possibly every 10. So what will happen into the future, particularly with the increased temperature and seeing this interacting effects of increased temperature, CO2, and the hurricane frequency is what's like triggering the system to different functional types.
So I think we are about an hour. I just want to say that I made my career publishing a couple of papers saying that forests are super resistant to all sorts of returns, to saying afterwards they are not, they are super fragile to creating redundancy, and we want to get super manual, and so just a word of caution there. But I'd like to thank everyone for being here, and then so let's applaud and you have their contacts and their bios, and Grizelle will be here for a few more days. And so have the opportunity to talk to her and then contact these amazing speakers. Thank you so much, Simon, Yadvinder, Deborah, for being here. And thanks again for the students to creating this opportunity for us.
Thank you. Enjoy the conference.